Welcome, everyone. Welcome to the session, Best Practices for SAP Deployments on GCP. My colleague Babu, Tech Lead, SAP on GCP, and myself will cover with you today. We have prepared the following agenda. First, I will give you an overview of GCP in the context of SAP workloads. I will do that by mentioning typical components of a SAP deployment on GCP and recap the most important things about these components. A short note, on some of the slides you will find some references to related sessions to the content shown on the slides. Then my colleague Babu will give you an overview of SAP in the context of GCP. And we'll move on to best practices and reference architectures. Then I will take over and will present some migration best practices and options how to bring your workloads to GCP. Finally, we will show a short demo and have a Q&A. So let's start with giving an overview of GCP in the context of SAP workloads. If you look at a typical SAP deployment on GCP, it normally consists of the following components. First, you need to think about how to connect to GCP data centers. Second, you need to think about a proper networking setup. Third, you need to think about compute resources where you want to host your SAP workloads on. And you need to think about storage, either with the VM as persistent storage or globally through our global storage offering, GCS. Then another aspect is you want to be sure that about the health of your systems. This can be achieved via monitoring. And finally, the whole thing is summed up via our built-in security concepts. So let's talk about compute. What you have to remember is that the network throughput scales with the amount of CPUs, maxing out at 16 gigabits per second. Through live migration and active auto restart, we can provide you with higher reliability. That means that during a software or hardware update, the VM is moved to another host transparently. This gives you better resilience for all levels below the operating system. Through sustained use discounts, a customer has the choice to and only pays for what they use, meaning the longer they use a resource in a month, the more discount they get. Moving on to persistent disk. As I mentioned before, with Compute Engine, throughput and IOPS scale with the size of the disk. And depending if you're using HDD or SSD, you have different read or write metrics, as can be seen here. For SSD workloads, which are our higher performance option, you have 800 bytes per second read and 400 megabytes per second write. Another deciding factor with SSDs is the amount of vCPUs. You will reach this maximum performance metrics only if you have more than 32 CPUs. Additionally, worth mentioning is that our persistent disk can save up I/O capabilities to handle I/O spikes well above the average. And also worth mentioning is that typical operation tasks like partitioning and redundant disk arrays, as well as sub-volume management, are not necessary with it. Now moving on to networking. When we talk about our software-defined network and compare it to a typical on-prem deployment, our VPCs can span regions, meaning they are a global resource. Our subnets can span zones, meaning they are a regional resource. They can have non-overlapping address space and can be dynamically extended. Through shared VPCs, we provide you the possibility to have a VPC as a shareable resource that can be managed by a central networking team. And another thing is to consider when talking about performance. For intra-VM communication, use internal IPs over external IPs and rightly size your TCP window. Now talking about how to connect to GCP. You have the following options. For low bandwidth, connections which are connecting via the public internet, you can use VPN, which provides you 1.5 gigabits per second. If you want to save up to 50% on egress costs compared to the VPN option and want to connect via public IP, you can either use direct or carrier peering, depending if you meet Google's peering requirements. If you want to connect via private IP and want to have an SLA, then you have either dedicated interconnect or partner interconnect. Dedicated interconnect provides you with 10 gigabits per second per link. Partner interconnect provides you with a range of 50 megabits per second or 10 gigabits per second per link. Talking about security, in this context, especially encryption, Google encrypts all data by default with Google's internal keys. But additionally, Google gives you the option to use customer-supplied encryption keys, meaning that you provide us the keys, keep them on-premise, and only if we want to retrieve or store data, we need them. In between, we have cloud management service that lets you keep keys in GCP, have them automatically used by GCP as needed, but control things like key rotation or the revocation of the keys. Now moving to the last point of those components, monitoring. Through our joint work with SAP, we could provide specific stack driver agents which hook into NetWeaver and HANA. They can give you the possibility to see in one singular view the health and detail about your SAP deployment on GCP. Through stack driver's alerting mechanisms, you have the possibility to get notified in case of any incidents. And through aggregated logging, you have the possibility to get a high-level overview of your SAP deployment amongst multiple projects. With that, I will give it to my colleague Babu, who will now show you an overview of SAP in the context of GCP.
Thank you, Jeremy. Can I have a quick show of hands? How many people here have experience running SAP workloads? Okay. How many of you have experience running SAP workloads in the cloud? Any cloud? Okay. So that's okay. Cool. So in this section, I'm going to cover two important things, two important topics. The first topic is what SAP services and solutions are certified to run on GCP. And the second topic is what are the benefits of bringing your SAP workloads to run on Google Cloud Platform. So we have been working with SAP starting from Q1 of 2017 for multiple certifications and technology integrations. We've come a long way in the past 1 year. We go through a rigorous functional and performance testing for each certification that we make available for productive use for customers. If you look at NetWeaver, we run something called as a 3-tier benchmark to prove linear scalability of our virtual machines. For example, we will take the NetWeaver stack, we will run the application on a single VM, we'll create the database on a separate VM, we will run the SD benchmark, we will look at the SAPS numbers. SAPS is SAP's application performance standard. Let's say the SAPS numbers is 100, for example. If you create another VM and you run the same workload with 2 VMs, you should get 200 SAPs. That's basically, you prove linear scalability, that's when you get certified. We have a few NetWeaver colleagues here who can attest to that. So we go through all of that to make sure that customers have the best possible experience when they are bringing their SAP workloads to run on GCP. We have also certified custom VM types for customers to run their S4 HANA workloads on Google Cloud Platform. What this essentially means is, let's say you do a sizing exercise, and you determine that based on the SAPs that you need an instance with approximately 20 cores. But if you look at the predefined machine types available in many platforms, including Google Cloud, you will find a 16-core machine and a 32-core machine. You will not find a 20-core machine. That's when custom virtual machines will help you. right? So with this certification, you can run machines, virtual machines, with the exact amount of cores that you need based on the SAPs that you have. Basically, if you look at the 20 core versus the 32 core comparison, you're basically saving 60% in terms of resource and cost just by using custom VM types. We've also worked with SAP to certify SAP Cloud Platform for Google Cloud Platform. So if you're a developer who's developing Cloud Foundry applications, SAP-based applications, this is a platform that you can leverage, and you can build custom applications on top of GCP with SAP Cloud Platform. SAP HANA is an in-memory database that serves as a backing store for SAP applications like S4HANA, BW4HANA, and so on. Customers who use SAP HANA require VMs with a large amount of memory. So the slide here shows a rapid pace of innovation that allowed us to go from 200 gigabytes of memory, roughly, last year, to 4 terabytes of memory this year, within a span of a year, right? And through this process, we also realized that you can run scale-out workloads, where you can scale out your SAP HANA from a single machine to multiple machines in a BW OLAP environment. So our scale-out certification currently allows you to go up to 16 nodes and 22 terabytes for your BW OLAP workloads. Finally, we have also certified dynamic tiering. This is hot off the press for SAP HANA workloads. So if you look at SAP HANA is an in-memory database. Memory is expensive. So, and if you ask the question whether your application requires all the data that's in memory, maybe, maybe not, right? So you decide at what point the data becomes less interesting to your application, and you define a warm tier to move the data to the, let's say, the dynamic tiering portion, right? This basically allows you to optimize costs and also leverage the SAP HANA certified ecosystem for storing large amount of data at the same time, right? And during this process, we also made sure that customers can deploy SAP HANA in our environment in a matter of minutes. We developed automation templates. These automation templates can do end-to-end stuff, starting from configuring virtual machines with the required amount of storage, certified configuration, making sure high availability is configured, making sure that there is automatic failover. So for example, if one machine fails, the other machine automatically takes over within a matter of seconds, right? So you can satisfy the high availability and disaster recovery requirements that you have in mind already. So this is just an overview slide talking about a summary of what we have achieved so far. So now let's move on and talk about benefits. Why should you bring your SAP workloads to run on GCP, right? So Data Custodian is a partnership initiative between SAP and Google Cloud in the GRC space, the governance, risk, and compliance space. Google Cloud, we developed a solution called AXT, Access Transparency, which is a set of APIs that will expose to customers what is happening in your infrastructure, who is accessing your data from the infrastructure provider side. So this is bundled into the Data Custodian application to provide more visibility, where SAP acts as a data custodian for customers' data in Google Cloud. This is a unique initiative in the public cloud space, only between SAP and Google Cloud today. I talked about dynamic tiering integration earlier. What if you have a use case where you have petabytes of data, and you have to store these petabytes of data and query the data at the same time with high performance? This is where integrations like BigQuery come into picture. With dynamic tiering, you have basically defined a hot and a warm tier. What if you could define another tier where you can take the data that is, let's say, greater than a year or greater than 3 years, depending on your application needs, and move it into, archive it off to BigQuery. But the problem is, when you archive it off to another store, you have to manage it, right? But the thing with BigQuery is a zero-ops data warehouse, which means that there is no servers, no software for you to manage. You just create a table, and the table just scales to the load, to the data you throw at it, to the queries you throw at it. There is no concept of servers at all. It's a serverless data warehouse, literally, right? So now this basically allows you to have another layer, scale to petabytes of data without incurring any operational costs, right? So how is this possible? You can basically make this possible through leveraging multiple technologies, like SAP Data Services is one, Data Hub is the new kid in the block for all the workflow orchestration and data processing applications. You can also use Dataflow, which is another serverless data processing application to archive data off to BigQuery from within SAP HANA. Now what? Now you have data in SAP HANA, you have hot and warm tiers, now you have data in BigQuery also. How do you get a 360-degree view of all your data for good analytics processing, right? So this is where we innovated with SAP to make BigQuery as a native option available through Smart Data Access. What this essentially means is the BigQuery tables can be virtually accessible through SAP HANA using Smart Data Access. So now you can do things like creating a view that encompasses, let's say, the hot, warm, and cold tier with BigQuery, bring them together. So when you do the query, based on what you're accessing, the query is pushed down to whichever layer the data exists, and you get the results back. One thing you should not do here, you should probably not run full table scans on BigQuery, because when you do that, you're basically going to page out all the active data in memory sitting in a SAP HANA database, right? But then if you run queries that materialize data, you can just get the process results back, because SDA just pushes the query down directly to BigQuery. Now let's talk about machine learning. I'll just talk about one portion of this here. We have partnered with Deloitte, and Deloitte has actually built a cool solution to solve the invoice management problem. This is a business process problem. So the solution looks like this, right? Let's say you have invoices that you're getting, and you need to input these invoices, digitize these invoices in an S4 HANA system, right? Typically, you would have a data operator. He will read the invoices, who will input the data in the S4 HANA system, and then he has to basically copy the invoice data, store it somewhere reliably, right? What the system does, what the solution that Deloitte has built, is it uses Google's machine learning technologies with OCR, and you can basically take a picture of the invoice, and the solution tool will basically extract the textual information from the invoice, populate an invoice, a digitized invoice in S4 HANA system, takes the original picture of the invoice and stores it in a cloud storage system reliably, right? This is all done with a single solution, and I've actually mentioned where the solution is where the session is happening. That's happening tomorrow. I would recommend for you to go and take a look at it. So if you are doing it yourself, you can develop continuous machine learning deployment pipelines. For example, this is an example where if you have data in SAP HANA and you want to derive intelligence from that data, using the power of machine learning available in Google Cloud, you can take the data and throw it into Google Cloud Storage, and then you can use TPUs, which are tensor processing units available in Google Cloud. You can provision them as much as you want and scale independently, and then develop your machine learning models, and then bring them to TensorFlow serving. Now, HANA can basically consume all the machine learning models through TensorFlow serving hosted on Compute Engine, right? So you can basically do continuous model training. You can, as new data comes in, train it, bring it back into TensorFlow serving. New data comes in, train it, bring it back to TensorFlow serving. You can build a continuous machine learning model. Google has been innovating in the containerization space. We have been running containers for a decade or so. And we open sourced Kubernetes. We also have a service called Google Kubernetes Engine, which is a managed version that allows you to manage Kubernetes services running in Google Cloud Platform. SAP has standardized many of their applications to use Kubernetes, right? So when you're thinking about applications like SAP Data Hub or Vora, they are standardized on Kubernetes, which means that you can leverage the managed Kubernetes platform that we have. You don't have to manage any servers, services, pods. Everything is fully managed for you. You just know Kubernetes definition, the container definition files, and you just basically can run these workloads with minimal operations. So this is a quick demo, an architecture showing how you can leverage Data Hub to bridge the Google and SAP ecosystem together. Data Hub also has native integrations. The newer version of Data Hub will have native integrations with BigQuery, PubSub, and Google Cloud Storage. So if you're basically developing big data processing applications, you can use Data Hub to bridge the Google and SAP technologies together. So what are we doing for developers, right? So we worked with SAP to enable Cloud Appliance Library. So today, we have 80+ solutions available in Cloud Appliance Library for GCP. So if you want to get started quickly and build a sandbox environment and play around with GCP, you can get started with Cal immediately. So let's talk about business continuity. Google Cloud exists across 17 regions today, and we are going to launch 3 more regions by the end of this year, so we'll have 20 regions. And all these regions are connected by Google's backbone network, which means that you basically have access to low latency networking for all your infrastructure needs. Plus, within the regions, we also have the concept of zones, where you can architect your applications to leverage multiple zones. And these zones are typically the zone-to-zone latency is under 1 milliseconds at the P95 level, right? Which means that you can leverage multiple zones and build highly scalable applications across these zones. You can also develop DR strategies using, let's say you're using HANA system replication. You can configure asynchronous system replication across regions and develop like a minimal RPO RTO solution. Let's talk about best practices and reference architectures now. So everybody must be familiar with it, right? I mean, whoever has SAP experience. So this is a typical sizing exercise that you go through when you size your SAP workloads. So you have the SAP Quick Sizer. You input all your data as to how many users you have, how do you scale, data edging, and all those things. And then it outputs a SAPS number. And then you take the SAPS numbers to the infrastructure provider. In this case, it's GCP. And we will take a look at the numbers. So you can basically take a look at our SAPS numbers in the SAP node. And then you can map the instance types that you want for your workloads based on the SAPs that you have. I talked about custom VM types earlier, right? So let's say you have a SAPs number. Let's say for 16-core machine, you have 32,000 SAPs, and 32-core machine, you have 64,000 SAPs. But what if you have a SAPs need that is 40,000? That's right in between these two, right? This is where you can leverage custom VM types for your workloads and basically optimize your costs. For SAP HANA, this is a simple algorithmic representation that I put together to size your SAP HANA workloads. So there are 4 factors that you need to consider, right? The first factor is what source database are you migrating from, if you're migrating from something else. If it's a row store database like Oracle or SQL Server, then you typically have to accommodate the compression benefits that you will get. Typically, it could be anywhere between 5x to 10x. So if, let's say you have a 20 terabyte Oracle database, you would size it at roughly between 2 to 4 terabytes for SAP HANA, right? That's factor number 1. Factor number 2 is whether you're looking to any data edging solutions, like using dynamic tiering or extension nodes and so on, right? So when you do that, your memory footprint drastically reduces. That's another way of optimizing your memory footprint costs as well. The third thing is if you're running OLAP workloads, typically SAP HANA has memory overheads. For example, when you're running queries, it uses temporary space to store the data in between during the processing, right? So you have to accommodate for those memory overheads as well. So that will be around 25 to 50%. The fourth thing is accommodate for future growth. You're running a database. You're going to get data in constantly. You cannot predict for what's going to happen today. You have to predict for what's going to happen down the line, right? But in the cloud, you don't have to plan for 3 to 5 years, because the only thing that you have to do to scale your infrastructure in the cloud is basically stop and start on a larger machine, right? But then you still have to plan at least 6 months to 1 year in advance. That's something that has to go into your sizing calculations as well when you're doing sizing for SAP HANA. So when you are running NetWeaver workloads on GCP, this is something that is mandatory for customers to install to get productive support from SAP. This is a Matrix Agent that we worked with SAP to develop. This agent gets you infrastructure level metrics and surfaces it to the SAP host agent, which will then consume these metrics. This will give you a single pane of view of whatever is happening, not only from the SAP side, but also from the infrastructure side to the customer, right? And this is something that's absolutely mandatory if you want productive support from SAP for your SAP workloads running on GCP. So let's talk about networking best practices. So one of the first decisions that you make after the sizing and everything is basically like which region do you want to deploy your workloads in, right? So you choose the region based on multiple factors. I've represented like 3 factors here. The first one is, where does your business process run? You need your region, your infrastructure to be hosted closer to where your business process is running or where your client is. That's the first thing. Secondly, let's say you have a tie between 2 regions. How do you decide which region you want to choose, right? So GCP or any cloud provider for that matter will have different pricing across different regions, right? So that's something that you need to consider. You cannot assume that the pricing is similar across all the regions that we have across the cloud. That's not the case. So you'll have to look at pricing. That's the second thing. Third thing is, when we launch new instance types, we eventually will launch these instance types across all the regions. But intermediately, these instance types are going to be available only in specific regions. So when you are thinking about your deployments, you should look at what instance types you're choosing and whether these are available in the regions that you are choosing, basically, right? Or choose a different region based on the availability. And when you are setting up your infrastructure, leverage private IPs for cross-node communication. This is a good practice, especially for latency and costs. And when you want to access Google Cloud Platform services like GCS, for example, to store your backups and other things, offload backups off, you can basically leverage private API access, which means that your virtual machine doesn't have to have an access to an internet. But with the private APIs that you have, you can access the Google Cloud APIs services natively. The other thing is, in any SAP installation, you have a specific IP protocol port combination through which traffic flows across the system, right? For example, you have administrative components like SAP router or solution manager that will basically talk to the application stack. And within the application stack, you have NQ replication server. And then you have central services that talk to each other for HA. And then from the application stack, you talk to the database, right? There is a defined traffic flow in your SAP installation, right? You can design that traffic flow by using network tags in our VPC environment today. Now, there are going to be cases where you want to go out of the VPC network to the internet to get packages and things like that, right? So that's when you leverage NAT, right? So in Google Cloud, NATing is implemented differently through a solution called ECMP NAT. ECMP stands for Equal Cost Multipath, where you can scale your NAT environment by just adding more instances and adding those instances to a routing table so that it routes the packets that are not belonging to the network or not targeted to the network to the NAT instance, right? So Jeremy talked about how our network egress bandwidths are. We scale up to 16 gigabits per second for machines 8 cores and above. So if you want to get higher bandwidth than this, then you can basically use an ECMP NAT solution and scale it independently and get how much ever NAT bandwidth you want. So let's talk about storage. So one thing that we absolutely recommend is to avoid using local SSD for your SAP HANA or your applications. We have certified and tested using persistent disk, which is basically network-attached storage. If you look at the persistent disk sizes that we have supported, you need at least 1.7 terabytes, because that's basically when you get the optimum storage throughput for your data and logs that you host on an SAP HANA. For backups, you need at least 2x the size of DRAM so that you can accommodate at least 2 full backup copies of your SAP HANA database. There are several cost optimizations that you can do. For example, if you have your management components like SAP Router and Solution Manager in a DR environment, you don't have to have a VM and disks running on the DR site for these management components. You can just take a snapshot of these components, and those snapshots can just live there in a DR scenario. You can use the snapshots to bring up your entire system together, at least the management components. So you can do some of these things to optimize in terms of costs. NFS. NFS is actually one of the major components in any SAP installation, right? So we have an avoid option, which is definitely something you should not do. But then you also have do-it-yourself and GCP Marketplace. For example, in do-it-yourself, we typically recommend leveraging the NFS services that is provided by the operating system provider. We also have single-node filer solutions available in our marketplace. If you look at the availability SLOs that Compute Engine provides, we offer 4 nines of availability SLOs for a single VM running in a single zone. This is basically leveraging reliability features like live migration, automatic instance restart, which make sure that your VMs are up and running always, even in case of failures, right? So a single node filer will typically satisfy your SLA requirements if they are under 99.99% of availability SLOs. We are also coming up with new solutions. We have announced new solutions. Those are going to be coming up in GA by the end of this year. So in terms of operating system images, right, you're not going to just take whatever images that we provide that are available to you and just use it, right? You're going to apply some customization to these images. When you're applying customizations to these images, you will have to look at 2 components. The first component is what portions of this customization do you need every time a VM comes up, and what portions of this customizations do you need to be updated once every 3 months, right? So these are static and dynamic components. The static components need to be baked into the VM image. This will allow you to improve boot up times so that when a new VM comes up in case of a failure on some event, you have a faster boot up time for your VMs. But the dynamic things, we cannot do anything about it, right? That depends on how you pull the packages in. There are a couple of Compute Engine best practices that I want to talk about here, right? By default, you need to enable live migration and automatic instance restart for all your SAP installations. This absolutely needs to happen because we have seen clear benefits when there are infrastructure events, when there are instances going down, when there are security events. We live migrate your virtual machines without any downtime to your applications. Without this enabled, your VMs will basically crash, right? So this is something that you need to do. You should also limit API access to specific GCP services from within your VM. For example, typically in SAP installation, you don't access many services. You don't access App Engine. You don't access like PubSub and things like that, right? So, but you might access things like BigQuery and Google Cloud Storage. So when you're creating these instances, restrict access only to those APIs that you absolutely need access for. Now, let's talk about a few reference architectures, and then I'll close. So this is something where we show a SAP HANA HA reference architecture. We have SAP HANA Primary hosted in Zone 1. And you have SSD persistent disk for all your data and log volumes so that you can satisfy your storage and throughput requirements. The backups are returned to HDD. That's another cost savings that you have. Now, once you have this enabled, you can create a similar setup in Zone B. You can do the initial data load, and then you basically have system replication configured. You'll have a synchronous data replication, which basically works because the zone-to-zone latency is under 1 millisecond. And you can configure backups to cloud storage at this point, right? So in the high availability setup that we recommend, you can also configure automatic failover, which means that if zone A entirely goes down, Zone B, whatever is running in Zone B, will take over and start running your database as if nothing happened in a matter of seconds. Similar thing can be applied to asynchronous replication in a DR scenario, where you will have the databases across region A and region B. And then in this case, instead of configuring synchronous replication, you will have asynchronous replication, because you don't want every write to block on a cross-WAN network. So you basically configure asynchronous replication to achieve this. So now in this case, you can reduce your RPO and RTO requirements because there is somebody who's waiting hot on the other side to take over in a case where the entire region A goes down, right? Now let's talk about Scaleout. Sorry about all this animation. So in a Scaleout environment, we typically recommend installing it in a single zone. You will have masters and slaves. All the master and slave configuration should live in a single zone. One difference here is that all the nodes in a scale-out cluster configuration should have their own persistent disks. Do not use NFS for data and logs in a scale-out environment at all. Use NFS only for HANA Shared. For data and logs, they're all on their independent volume. We are currently working on announcing a solution for high availability for scale-out clusters in HANA using the concept of standby nodes, but that's something that's not out there yet. But meanwhile, you can basically leverage instance reliability capabilities like live migration and automatic instance restart. So, yep. So I'll now hand over to Jeremy to talk about migration. Thank you.
Thanks, Babu. Thank you. Hear me? Excuse me? Perfect. Since we have now covered the possible reference architectures and best practices, let's go over to some options how to move existing workloads to GCP, given that you have a proper network connection to our data centers in place. Yeah, the first option I will cover is VeloStrata. VeloStrata is a solution that allows you to quickly move workloads into GCP. It thereby takes an agentless approach and does some specific optimizations when moving data into the cloud. It takes a streaming approach and performs a native boot over the wide area network to on-premise operating systems. So while the operating system boots, it is adapted on the fly to meet the cloud environment requirements, and then streaming starts. So only the data that you need to work with your workloads in the cloud is streamed to the cloud. This technology is called intelligent streaming, and you can, after a few minutes, you can already use your compute resources in GCP. Meanwhile, transparently, the rest of the data is migrated to the cloud. And finally, once the synchronization is done, you can do the switch over to the VM in GCP and still take or keep the backup that you have on-premise. VeloStrata uses some specific optimization technologies like multi-tier caching, deduplication, asynchronous write-back, and network optimizations to speed up this process. Another option that you have is Cloud Endora. Cloud Endora takes a little bit of a different approach here. It uses an agent-based approach, and it offers a central management console that allows or migrate the data, but also do disaster recovery. So as soon as you install the agent on your VM, the streaming starts. And in the GCP, the Cloud Endora servers are set up and do the replication. The block level copy approach in difference to VeloStrata, which uses a streaming approach. And once you have done the migration and finished your testing, you are ready for the cutover and can start using the machine in the cloud. And you can decide if you want to remove the agent or if you want to keep on the regular data replication. So now that we have talked about some options how to move the data as is to the cloud, I will show you some scenarios how you could use these tools. Scenario one or option one is you want to do, in a first step, a simple lift. Use a tool like Cloud Endora or VeloStrata to move your data as is to the cloud and already get the first technology refresh. However, you will still have your technical depth and need to address this at a later point in time. Nevertheless, since you are already in the cloud, this is a much easier step. So many customers do this because they have to go off of their current platform due to contract expiration, capacity limitations, or other non-technical reasons. So the option of moving quickly takes precedence. The other option that you could use, or the other scenario that you could use, is to use DMO for that. And since DMO normally is an in-place procedure that just works on the same application server, you could use DMO with systemo for that. That allows you to migrate to another application server. Therefore, you can move your workloads to GCP with this approach. And so if you want to bring your workloads to GCP, we work with various partners. We have a partner ecosystem that you can use to implement your SAP workloads in GCP. And Babu already mentioned some of them, for instance, Deloitte, Accenture, and others. Now that I have shown you the migration part of the picture, I will move on into the demo part of the session. So I have prepared for you the following demo. Babu mentioned it before. We have the possibility of deploying a high availability setup on GCP. And this can be achieved via Deployment Manager, which is our infrastructure as a code tool. We have provided Deployment Manager templates, which you can leverage and deploy a high availability setup in GCP. It uses Linux clustering and a virtual IP address to do the simple switchover, as well as HANA system replication. So now, let me start the demo. As you can see on the first screen, this is the bucket where you normally store the HANA files. So you have a GCS bucket, which you will reference in the Deployment Manager template. So this describes actually the high availability setup. And further down, you can see the command which executes this setup. You can also see the sample output of a working installation. Now I switch to Stackdriver logging, where you can see how the normal logging output would look like on a typical HA deployment on GCP. You will find some references to the buckets you were using, as well as the IP addresses that are used, and the virtual IP addresses that is shared amongst those two instances. And finally, once the whole setup is done, you are greeted with the message instance deployment complete. So you know the deployment has been finished. And I'm switching over to HANA Studio to show that the deployment works. And you can see all services are started, as well as the replication service is started. You see the VM1 as the primary host and the VM2 as the secondary host, and the replication type that is used. Now I log on to VM1 and will try to start a failover, meaning I will shut down the one VM and show you how the failover happens and how the takeover is happening. So I log on as administrator and simply shut down the network interface. In Google, that means once the network interface is shut down, the VM automatically restarts. Now again, I move to Stackdriver logging, which shows you exactly what is happening in the cloud. In this case, it shows you, okay, a VM is going down. As you see, I have to refresh a little bit. It takes a couple of seconds. And you will see then that the system detects, okay, a VM is down, and it does the takeover. You can also see that the virtual IP address that I mentioned before will be changed to the other host, to VM2. So as you can read, it's issuing a reset to and check. It's seeing that the VM is going down, and the 10.1.24 is the virtual IP address that is shared amongst the two instances. Now the VM2 is taking over. And I switch back to HANA Studio to show you exactly that first the system or VM2 has taken over. The synchronization is not currently running. It takes a couple of seconds again until the synchronization is properly set up again. So you can see now it says VM2. So it has switched the primary host from VM1 to VM2. And you can see I'm getting a little bit nervous. What is happening? But now you can see the synchronization is also kicking in. The primary host is VM2, secondary host is VM1, and the replication mode is coming up. So it takes a couple of seconds, of course, when the VM1 is back up, that the replication can be started. And with that, the failover is done, and you still have a running system. And as I said, this is all provided out of the box via our deployment manager templates. You have access to these templates. You can further look into the code that is written there. So it uses Jinja and Python to script this. And yeah, you can drill down and find out, okay, what is happening. You can also attach additional logic if you need, all to your liking.